are trying to be like Spider-Man, but it ain't gone away yet. It's Thursday, March 19th. Welcome to AP Computer Science with Mr. Barron, and I got a new problem for you. I got a 2D array of doubles where I'm changing some of the values in it. I want you to create a table that represents the 2D double array above, after all of these lines of code have run. This is your chance to show off that you understand array indexing and what creating a 2D array does. Go ahead and pause your video, try it out on a whiteboard or piece of paper. And when you're ready to, play again to move on. We'll go ahead and talk about your bell work, your day to start things off. I'm going to take these lines of code and go ahead and throw them in my workplace. And let's go through this line by line. Okay? Our first number in a 2D array, in case you've forgotten, always represents the number of rows, and this always represents the number of columns. So, if I want to make a table that shows this off, it should look something like this. 3 rows. And as a class, go ahead and shout out what number always gets filled in when you initialize a 2D array. Oh my gosh, guys, you're totally right. It's 0. Nice work. High fives all around. Sweet. So now we got these 3 lines of code. They're going to take and fill in our values. 1, 1 is going to change the value in the second row because it's 1, and the second column. So we'll go ahead and change this to 0.6. 2, 1 is going to change the value in the third row, the second column. So we'll change that to 0.7. And 1, 0 is going to change the value in the second row in the first column. So we'll go ahead and change that to 0.8. And this is what your initialized array values are going to look like after you change these lines of code. The important thing to remember is just like any 1D array, indices start. So if you see 1, it's in the second row. If you see 2, it's in the third row. If you see 0, it's going to be in your first. Hopefully you're feeling good so far about how 2D arrays are created and how they're indexed. If you need to, I suggest you either email me or you stop right now and review your materials from last time, because you're going to need to know about indexing as we move on from here. A couple of quick reminders. Welcome back. Just like last time, we have a little haiku page for today, and underneath the agenda, there's some helpful links. Every single example that I go through will be under Unit 8 Writing 2D Array Examples, and it will pop up this March 19th, 2020 class example notes link. You'll notice exactly what I just did for your bell work is right here. And every single thing we talk about in the coming days will also be, or in the rest of the class period, will also be included in this list. Okay? I'm going to tell you right now, and I'll tell you about 3 times. You do have a little homework assignment tonight, an IP, on running algorithms on 2D arrays. The problems are listed here, but you should submit it and complete it on Google Classroom. It is 5 questions, 2 conceptual questions, and 3 little methods that you'll write tonight. Here's our plan of attack. We just spent a little bit of time reviewing last class and how to define and index 2D arrays. We'll talk a little bit more about how 2D arrays work as arrays of arrays today. We'll start talking about how to run multiple for loops on our 2D arrays to process them effectively. And you know already how to create algorithms on 1D arrays, even if you don't remember exactly what that's like. You learned it. We've gone over it a number of times throughout the year. We'll make sure that we're feeling good about how to do that on 2D things. Thanks so much for completing your e-learning assignment. If you did it on Tuesday, that was awesome. Was really excited to give you all feedback. If you haven't done it, maybe before you advance into this video today, it'd be a good idea to go back and finish that up. We are allowed to take e-learning assignments late, but I do expect work to be done by 5 o'clock, just as I expected for today's class period. So let's give ourselves a few little reminders about how to write algorithms for normal arrays. Write an algorithm that uses a for loop to add up all the values in a 1D array named numbers. You'll need an integer named sum to do that. Write an algorithm that counts up the number of words that have more than 5 letters in a string array called words. I'm expecting that you'll be able to do this kind of thing, harkening back to a lot of the things that we did last semester. Go ahead and pause your video on a piece of paper in Dr. Java, work on these for a couple minutes. And when you're feeling good about that, press play again on the video, and you can check your solutions against what I have. In case it's helpful to have some example code, for how to complete these two things, let's give ourselves a little reminder in fancy font of how to write algorithms using for loops. Okay. We'll assume here that you have a 1D array named numbers. And the goal is to add up all the values in a 1D array. So I'm going to need a number to keep track of this. I'll come up with an int named sum and set it equals 0. Now it says you'll need a for loop to do this. So one of the two main points I want to go over today is making sure that we're feeling comfortable with for loops. Remember, syntax starts at 0. For an array, we want to keep it less than the value of numbers.length. Why do we want to do that? Ask yourself for a moment. Remember that our biggest index will always be 1 minus the length, so we'll keep it below here. And we want to add up the values of every one. Remember, we use sum plus equals to continually add to a variable. And to access each of the values in an array, I'm going to add numbers.x. Remember that using our index in the for loop and setting the counter in our for loop equal to the index allows us to access every index of the array list. Pause here, check yourself to make sure that you're feeling good about that code. When you're ready to move on, press play, and we'll do our little string example. We also want to make sure that we're comfortable manipulating and making string arrays. And in this case, I want to count something. I'll define an int named count and set it equal to 0. We've already talked a little bit about how to define for loop. that'll loop from 0 to the length minus 1. And we want to make sure that we can process arrays of strings and use the appropriate string methods. As a class, go ahead and shout out what method you used to check if there were more than 5 letters. Hey, you guys are right, it's length. And I'll add to the count if each one is greater than 5. Remember words.x.length checks v to see if each word in the string array has a length of greater than 5. Words x represents each individual string. If I just put words.length, like I did here, that's a little different because that checks the length of the array, checks how many words are in the array. This is going to check a particular number of letters in each one. Super, super, super important that you feel comfortable explaining what each value of length means, because in this problem, we're kind of counting through two things, right? We're counting through the number of words, and then we're counting through the length of each word. It's going to get a little bit more complicated as we go from here, because we're actually going to start looping through even more things. Before we move on to our new content for today, I'd actually like you to go ahead and complete problem number 1 on the IP, which again is available on Google Classroom. It looks like this. It just asks you, what did you learn from reading the feedback on last night's homework? The reason I'm stopping you now to do this is because your homework is a review and gives you some feedback on 2D arrays in general. We just went over how to solve algorithms of 1D arrays. If you need either of the examples about running algorithms on 1D arrays, I've got it directly at the bottom of the first page and the top of the second page in the class example notes on Haiku. Make sure that you're up to speed on those basics before we get into any new material here today. So I would pause this video when I'm done talking, complete problem number 1, make sure that you're ready to go, and when you are, move on to the second video.